morning, everyone. Welcome to your geometry class. Our lesson for today is Trapezoids and Kites, textbook pages 389 until 396. Our objective is to verify and use properties of trapezoids and kites. Let us first watch this video.
What is a trapezoid? Here we have an example of a trapezoid. But what makes this figure a trapezoid? Let's see if we can figure that out. Looking at this figure, we can see that it has four sides. Well, a four-sided figure is a quadrilateral. So that means that a trapezoid is a type of quadrilateral. But what makes it special? What makes it a trapezoid? Taking a closer look at the figure, we can see that this side and this side appear to be parallel to one another. And actually, if we extend out those sides, we can see that that is true. Extending out these sides, we can see that they're parallel. These lines will continue on and on without ever intersecting each other. So that means side WX and side YZ are parallel. But what about the other two sides? Here, side WY and side XZ. Those sides are not parallel. If we extend out those lines, they will intersect eventually. So that means that a trapezoid is a quadrilateral that has exactly one pair of parallel sides. No more and no less. Exactly one pair of parallel sides. Now notice in this trapezoid that the non-parallel sides are equal. But that's not always the case in a trapezoid. So let's take another look at a trapezoid. Here we have another trapezoid, and we can label it just like this. Now, if we take a close look, we can see that sides LM and ON are parallel. We have a pair of parallel sides. And the other pair of sides are definitely not parallel. But we can also see that they're not equal. So in order to be a trapezoid, we need to have a four-sided polygon that has one pair of parallel sides. Now sometimes figures can have more than one name, based on their characteristics. So here, let's take a look at some other figures and see if we can call them trapezoids. Well, we know that a trapezoid is a quadrilateral that has exactly one pair of parallel sides. And remember, a quadrilateral is a four-sided polygon. And since all trapezoids have four sides, all trapezoids are quadrilaterals. Great! Now let's look at some other figures. Let's take a look next at a parallelogram. A parallelogram has four sides. So, it's a type of quadrilateral. But to be a parallelogram, the figure has two pairs of parallel and congruent sides. So here, these two sides are parallel and congruent to one another. And these sides are parallel and congruent to one another too. Is a parallelogram a trapezoid? No, it's not. Remember, in order to be a trapezoid, we must have exactly one pair of parallel sides. No more and no less. A parallelogram has two pairs of parallel sides. That is one more pair than we can have to be a trapezoid. So a parallelogram is not a trapezoid. What about a rhombus? Let's look at that. A rhombus is actually a type of parallelogram. Except in this parallelogram, all the sides are congruent. They all have the same length. But a rhombus is a type of parallelogram. So it has two pairs of parallel sides. That means that a rhombus cannot be called a trapezoid. What about a rectangle? Let's take a look at that. A rectangle usually looks like this. It is a parallelogram where all the angles are right angles. But a rectangle is a parallelogram. So we have two pairs of parallel sides. That means a rectangle is not a trapezoid. Finally, let's take a look at a square. We actually get a square by taking a rhombus and a rectangle and putting them together. So here, to be a square, we need to have a parallelogram where all the sides are congruent and we have all four angles being right angles. But a square is a type of parallelogram. We have two pairs of parallel sides. So a square is not a trapezoid. So here we found that all trapezoids are quadrilaterals because all trapezoids have four sides. However, a parallelogram, a rhombus, a rectangle, and a square are not trapezoids because they do not have the correct number of parallel sides. In order to be a trapezoid, we need to have a four-sided figure that has exactly one pair of parallel sides.
So we have here problem 1 and get it 1.
In this problem, you will find degree measures of angles in trapezoids. Figure CDEF is an isosceles trapezoid, and the degree measure of angle C is 65. What are the degree measures of angles DE and F?
Problem 2 and got it 2.
In this problem, you will find angle measures of isosceles trapezoids. The second ring of the paper fan, shown at the right, consists of 20 congruent isosceles trapezoids that appear to form circles. What are the measures of the base angles of these trapezoids? What do you notice about the diagram? Each trapezoid is part of an isosceles triangle with base angles that are the acute base angles of the trapezoid. Step 1. Find the measure of each angle at the center of the fan. This is the measure of the vertex angle of an isosceles triangle. 20 angles meet to form the circle. Since the circle has 360 degrees, divide 360 by 20. So the degree measure of angle 1 is 18. Step 2. Find the measure of each acute base angle of an isosceles triangle. Use the triangle angle sum theorem. Remember, the measure of the acute base angles of an isosceles triangle are equal. So for this triangle, use x for each unknown base angle. Then combine like terms. Now subtract 18 from each side. And finally, divide each side by 2. So x equals 81. measure of each obtuse base angle of the isosceles trapezoid. Two angles that form same side interior angles along one leg are supplementary. Now subtract 81 from each side. So y equals 99. So the degree measure of each acute base angle is 81. And the degree measure of each obtuse base angle is 99.
Problem 3 and got it 3.
In this problem, you will use the mid-segment of a trapezoid. Segment QR is the mid-segment of trapezoid LMNP. What is X? Use the trapezoid mid-segment theorem, which says that the length of the mid-segment is 1/2 times the sum of the length of the bases. Substitute the lengths of the segments in this trapezoid. Now simplify each side of the equation. Use the distributive property to further simplify the right side. Subtract x from each side. And finally, add 1 to each side. X equals 3. How can you check your answer? Find the length of segment LM and the length of segment QR. Then see if the length of segment QR equals half the sum of the base lengths.
Problem 4 and got it 4.
In this problem, you will find angle measures in kites. Quadrilateral DEFG is a kite. What are the measures of angles 1, 2, and 3? By definition, the diagonals of a kite are perpendicular. So the degree measure of angle 1 is 90. Now use the triangle angle sum theorem to find the measure of angle 2. Simplify each side of the equation. Subtract 142 from each side. The degree measure of angle 2 is 38. Triangle DEF is congruent to triangle DGF by the side-side-side postulate. How are the triangles congruent by the side-side-side postulate? Segment DE is congruent to segment DG. And segment FE is congruent to segment FG because a kite has congruent consecutive sides. And segment DF is congruent to itself by the reflexive property of congruence. Since corresponding parts of congruent triangles are congruent, the degree measure of angle 3 equals the degree measure of angle GDF, which is 52. In this problem, you will find angle measures in
Thanks for watching.